This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 3, Lesson 9, Food Processing and Cold Storage Loads. This is the product load, the heat you pull out of the food itself. Freezing happens in 3 stages. Cool the product down to its freezing point, freeze it, then cool the frozen product to its final temperature. The handbook gives you the food data, and you assemble the load from Q equals MC delta T. We'll brown the 3 stages, then freeze a batch of salmon. Concept 1. The 3-stage product load. Freezing crosses a phase change, so the heat splits 3 ways. Stage 1. Cool the fresh food down to its freezing point, using the specific heat above freezing. Stage 2. Freeze it at that temperature, the latent heat of fusion, removed at constant temperature. Stage 3. Cool the now frozen food down to its final storage temperature, using the specific heat below freezing. The handbook prints no product load formula. You build it from Q equals MC delta T. Concept 2. The food data. The handbook table is purely data. For each food, you read its initial freezing point, a specific heat above freezing, a specific heat below freezing, and a latent heat of fusion. Pink salmon freezes at 28, with specific heats of 0.88 and 0.52, and a latent heat of 110. There's no equation on the page, just these 4 numbers per food. Setup. Since nothing is printed, we assemble the load from the specific heat definition. Sensible above the freezing point, latent at it, sensible below. The batch, 500 pounds of pink salmon, entering at 45 degrees, frozen down to 0 for storage. From the table, salmon freezes at 28, with specific heats of 0.88 above and 0.52 below, and a latent heat of 110. Only the 2 temperatures come from the problem. The rest is a lookup. Solve. Stage 1, sensible above, 500 times 0.88 times 17 degrees, about 7,500 BTU. Stage 2, latent, 500 times 110, 55,000. Stage 3, sensible below, 500 times 0.52 times 28, about 7,300. Add them, 69,760. The latent stage alone is nearly 4/5 of the total. Concept 3. Pull down. That 69,000 is total energy. The machine has to remove it over some chosen time. Bring the salmon down over 10 hours, and the required rate is the load divided by 10, about 7,000 BTU per hour, or a little over half a ton. The pull-down time is a design choice, not a handbook value. Cut it in half, and you double the capacity you need. And remember, a refrigeration ton is 12,000, not the 15,000 cooling tower ton. Concept 4. Why latent dominates. In almost every freezing problem, the middle stage swamps the other 2, because water's latent heat is huge next to a 20 to 40 degree sensible swing. For the salmon, it's 79% of the load. For a batch of apples, 72. So getting the latent heat of fusion number right matters far more than either specific heat or temperature span. Read that column carefully. Traps. 4 ways this bites. 1. It's 3 stages, not 1. Sensible, latent, sensible. Skip the latent piece, and you undercount badly. 2. Below the freezing point, use the specific heat below freezing. The water is ice now, roughly half the specific heat, which is why that column is always the smaller one. 3. Latent heat is added once, at the freezing point. It's per pound, never times a delta T. 4. Some rows show a dash for freezing point. Bacon, most pork, turkey, many juices, so you can't split the stages from the table alone. Quick recall. The product load is sensible above the freezing point, plus latent at it, plus sensible below. The 4 food numbers come from section 810. The Q equals MC delta T basis is the specific heat definition. To size the machine, divide the load by your pull-down time and convert to tons at 12,000 BTU per ton. Golden rule. Latent dominates. Read the latent heat column carefully and switch to the below freezing specific heat once you cross the freezing point. Next up, Lesson 10, Exam Strategy and Worked Refrigeration Problems. We'll run 4 timed problems end to end, a cycle COP off the pH chart, a compressor work and displacement check, an absorption COP, and a product load freeze. And hit the ton trap one final time. Everything's at peprepengine.com. Cheat sheet, work solutions, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com. Link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.